Hello everyone. Let us discuss example for bidentate and polydentate ligands. First one is abbreviation, that is ENE, and name of this ligand is ethylene diamine. Ethylene diamine. Formula is CH2 and here NH2 and NH2, right? And type of ligand is bidentate ligand. So it can donate 2 pairs of electrons to the central metal atom. If there is central metal, it can donate 2 pairs of electrons. Next is oxalate, OX2 minus. Okay, OX2 minus. Name is oxalate or oxalato. Why oxalato? It's oxalate ion, but we name it as oxalato because E is replaced by O in if it is anionic ligand. You will learn there in the nomenclature oxalato, and we can write it as C double bond O and O minus. Okay, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, oxalate is nothing but ion of oxalic acid. Oxalic acid, COOH, and if we replace this two, when it ionizes, it will ionize the COO minus. COO minus is nothing but see here we can write it as C double bond O as double bond O minus. See this O as C double bond O minus, one and the same oxalate ion. And this is again example for bidentate ligand. It can coordinate through 2 oxygen atoms, hence is bidentate. Third one is example for tridentate ligand, that is diethylene triamine. Diethylene triamine. That is you can write this only first, that is as CH2 and NH2, one group. This one CH2 NH2, again in between NH group. Once again CH2 and NH2. Here it can donate through 3 nitrogen atoms. 1, 2, 3. Hope it is clear for you. Diethyl triamine you can write this diethyl group, diethylene group, and 3 amines. Middle NH group will be there, right? It can donate electron through this or this nitrogen or this nitrogen. Hence, it is a tridentate. Tridentate ligand. Next one is EDTA. EDTA 4 minus, that is acetate ion, right? You can call it as acetato. Ethylene diamine tetraacetate. Acetate, E is replaced by O. Tetraacetate. And again it is same as ethylene diamine. First, look at this. You can write CH2 and CH2 two groups. To this nitrogen is attached. To this carbon also nitrogen is attached. Now you have to write acetic acid group, that is CH3COO group, and one H is replaced by this. Okay, hence it is CH2COO minus. Clear? And here also again CH2COO minus. I'll write it as C double bond O minus. Right? It can coordinate through this oxygen. Here also you can write in this way. Or that is more than enough. Again here CH2 C double bond O minus, right? CH3COOH is acetic acid, is acetate. Again CH2 C double bond O minus. You can represent electrons 1, 2, 3, 4. Here 1, 2, 3, 4, 5, 6 you can represent. Here also 1, 2, 3, 4, 5, 6 is there. 1, 2, 3, 4, 5, 6. This structure is there in your textbook. You can refer that. And simply I will tell how to write this EDTA structure is just ethylene diamine CH2 to CH2. These two hydrogens of nitrogen is replaced by CH2COH, CH2COH. Here also CH2COO, CH2COH is ionized. Hence it is instead of COOH you have to write COO minus. Right? Oxalato ion. Clear? It will be, where I'll write here, it will be CH3COOH acetic acid, acetato COO minus, and here one hydrogen is replaced by one nitrogen atom, right? Here it will be NH2 group earlier. One is replaced by this, one hydrogen is replaced by this group, another hydrogen is replaced by another group, COO minus. Same way another side. Hope it is clear for you. And how many acetate groups are there? Tetraacetate. 1, 2, 3, 4. Right? So that ethylene diamine tetraacetate, EDTA, and it is a polydentate ligand or a hexadentate ligand. Hexadentate, or you can write directly as a polydentate. How many coordination sites? Better hexadentate, or you can write polydentate. See here 1, 2, 3, 4, 5, 6. 6 donating groups are present, right? This is about hexadentate or polydentate ligand. Next, we'll move to the next topic, that is ambidentate ligands. What are ambidentate ligands? A ligand may contain two two or more or one or two or more donating groups, but it can ligate through one coordination site. Right? A ligand may contain more than one donating groups, but it will ligate through, or it may coordinate through one coordination site. Then are called ambidentate ligands. Ambidentate ligand. A ligand which contain more than one donor atom, or it can contain more than one donor atom in a ligand, but ligate through only one donor atom. It may contain more than one donor atoms, but can ligate through only one donor atom. I'll give example, then you will come to know. Example, NO2 minus. See here, it can ligate through either through nitrogen atom or through oxygen atom. Hence, nitrate ion is example for what? Ambidentate ligand. I'll write it as N double bond O minus 1, 2, 3, 4, 5, 6. Here lone pair of electron, and here it is 1, 2, 3, 4. Right? If it ligate or coordinate bond formation takes place through nitrogen atom, then is called nitrate N. If it takes place through oxygen atom, then is called nitrito O. That is, it represents through oxygen atom. And one more example is C triple bond N. Here also same. If it is through carbon atom, then is called cyano. And if it is through nitrogen atom, then is called isocyano. Right? Isocyano. And one more we can observe, that is cyanato. C double bond N double bond O. 1, 2, 3, 4. Also 1, 2, 3, 4. If it is through oxygen, then is called lone pair, okay, is called cyanato. If it is through oxygen atom, hope it is clear for you. If it donates electron, if it is directly bonded to central atom, then is called isocyanato. Isocyanato. Okay. Then one more is thiocyanato, that is C triple bond N, double bond N and double bond S. Yes. If it is bonded through this, then is called thiocyanato. Yes, bonded through sulfur atom. If it is bonded through nitrogen atom, then is called thiocyanato N. Okay, that is a ligand which contain more than one donor atom. That is, it contains nitrogen as donor atom, oxygen also donor atom. Sometimes it will bond directly to the central atom through nitrogen or through oxygen. If it is bonded through oxygen to the central atom, then is called nitrito N. If it is bonded to the central atom through oxygen, then is called nitrito O. Here also cyano or isocyano, etc. Hope it is clear for you. It will bond to central metal atom through carbon, cyano. If it is bonded through nitrogen, then is called isocyano, like that. This is about ambidentate ligands. Let us move to the next topic, that is chelation and chelating agent, or sometimes it is called or it is pronounced as chelation or chelation. Okay, chelating agent also correct, or chelation. Chelation and chelating agent. Here, when a bidentate or polydentate ligands coordinate through two central atom, and if it forms a ring while forming coordinate bond, if it forms a ring, then is called a chelation or a chelation. That is, chelation is a process in which a polydentate ligand forms a ring. A polydentate ligand coordinate to a central metal atom and forms a ring, and is called chelation, and this process is called chelation, and that ligand is called a chelating agent. Okay, and complex formed by this is called chelates. Chelation is a process in which a polydentate ligand bonds to a metal ion and forms a ring. Is called a chelation. The complex produced in this process is called chelate or chelate, and the polydentate ligand is called the polydentate or bidentate. Bidentate also can. Together we can call it as a polydentate. ligand. Here in the chelation, the polydentate ligand participated is called a chelating agent. Chelating agent. Okay, this is about chelation. Let us discuss one example. Cobalt, central metal atom. See, here it is ethylene diamine. It's a bidentate ligand. It can donate electron. Right? Next, I'll write it as one and the same, but in your textbook structure is given like this, so I'll refer that only. Cobalt, NH2, right? Again here CH2, bonded to nitrogen. Here nitrogen can donate electrons. Here also this nitrogen can donate lone pair of electron. NH2. Now it is more clear, right? One more. Right? See here. Now we can observe three ene groups, ethylene diamine. These three ene bident ligands form a ring-like structure. Hence is called chelate, or these ligands are called chelating agent, and this process is called chelation. Right? If you want, these are in a plane, you can show. Here it has not come same. You better refer textbook to draw this, okay? Because if it is come in this plane, then it is well and good. Like this, in this plane, all nitrogen atoms, or 4 nitrogen atoms in one plane. Right, like this. This represents a ene group. This represent ene group. This represent ene group. Okay. Like this. I'll try to draw. It must be this one plane, like this, single plane. Okay, this is about chelation. Let us move to the next topic, that is denticity. Here denticity is nothing but a number of ligating groups present in an compound is called denticity. Monodentate, bidentate, polydentate, etc. Right? The number of ligating groups present in a ligand. Denticity is nothing but number of ligating groups present in a ligand is called denticity. For example, EDTA denticity is 6. Why denticity of EDTA is 6? 6 ligating groups are there, right? 2 nitrogen, 4 oxygen, total 6. Or in how many? 2, right? 2 ligating groups are present. This is about denticity. Let us move to the next topic, that is nomenclature of coordination compounds.